Hey everybody, get this going here. You're going to see a lot of glare on this screen. I can't help that. I want to do an investigation. I haven't done a math notation video on my channel for a while, MathNotations vids. My Twitter account at @dmoraine and MathNotations, no space, you can Google, is also the name of my blog. So, in years past, I would simply call this an investigation, an activity to promote deeper understanding, making connections, and promoting dialogue in the classroom. Now, of course, I have to add Common Core as a modifier to make it more current. And this would it would bridge geometry-algebra-precalculus, and the focus, as always, is on instructional methods and the kind of dialogue we would like to see in the classroom to promote understanding and so on. So we're going to start out with an equilateral triangle, and it's not going to be a great picture, so bear with me. And the question is to inscribe a rectangle with the greatest possible area. So we ask our students to draw such a rectangle. Keep it a little open-ended. You don't have to tell them the base of the rectangle is on the base of the triangle, and see how creative they can be. But we'll move quickly to pictures like this. That's one possibility. Here's a second possibility, and so on. And ask them to make a conjecture within their group, reach consensus on where they believe or how that rectangle should be drawn to produce the greatest area. A square, perhaps, or other special case. Well, we're actually going to take one of their suggestions and start out with what will probably come up, either the square or the midpoints. So let's do the midpoint. And then we'll do the square, and then we'll move on to a more general discussion. And my contention is that this whole investigation takes place in less than half a period, and you can explore this with your group, use it any way you want, and it would be great if you could comment on the blog or on my video channel on YouTube what your reactions are. And again, the problem might be interesting, but far more important to me is the discussion about the teaching aspect, methodology. All right, so let's start with midpoints. Let's connect midpoints. Draw the rectangle. And what do we want our students to do to be successful in geometry or in general? Label diagrams, of course. And as obvious as that is, we do not see students labeling things clearly enough. To make this problem a little less abstract, let's agree from the beginning that in all cases, we're given the side of the equilateral triangle. We could, in general, call it a constant, give it a constant name like K. But since our focus is on other variables, I'm going to use 6 to simplify it somewhat. All right, so our objective right now is to find the area of this rectangle. We need to figure out the side. So we give our students a chance to try this on their own. After a few minutes and you're walking around the room, you could share some of the observations you've made within each group, and hopefully you'll see this, which is a key step. since this is 3 and 3 and 3 and 3, our problem then comes down to finding the height of this rectangle. And some students, without giving much thought to it, will forget that it's not necessarily a square. And in fact, that should be a good question. Why is it not a square? So let's call this side y for the moment, or x. Pick a variable, let them pick the variable. Hopefully they'll recognize that this is a 30, 60, 90. Somebody in each group ought to make that observation from geometry, whether they're in geometry or in a higher math class. And so we need to review, so I usually go off to the side, and this is something I've tried in the classroom. So this is 3, and in a 30, 60, 90 triangle, we know that the side opposite the 30 is half, the hypotenuse, 3 over 2. And the side opposite the 60, the longer leg, is 3 over 2, radical 3. So the area is base times height, so it would be 9 over 2 radical 3. Go to your calculator for this. And in teaching, you would have them do this, in my opinion, or you could have it on the smart board, the calculator built in, graphing calculator as part of your smart board, overhead projector, however you want to do it, 7.79, I believe. So that might be the first mistake if I mess that up, right? I'm doing this from memory, so I think it's 779. Rounded to 2 places. All right, so now you can ask the group, what do you think, folks? Do you think we have found the rectangle of greatest area we can inscribe in this particular equilateral triangle? Well, let's investigate. What would a mathematician do? And mathematical habits of mind is part of what our goal is here. And most students, I think, and most adults would have a hard time believing that research is such an important part of mathematics, as opposed to, we know all the rules, let's apply the rules and methods and procedures. All right, they had to come from somewhere, right? So let's record the 779. And that's part of doing research. So let's do case 1. All right. Equilateral triangle, connect midpoints. And just to remind ourselves, 3 and 3 and x. And x turned out to be 9 radical 3 over 2. And the area is approximately 7.79. The next case students might consider would be the square. So let's look at the equilateral triangle again, this time square. And you could ask, will the side of the square be less than or more than the side we obtained from the midpoints? Well, of course, the side we obtained from the midpoints is 3, since that was an equilateral triangle or some theorem about the midline of a triangle. Will this be less than 3, more than 3? We hope students would say less than 3, but that's a point of discussion. You could open that up if you wish, but we want to move on. So again, we mark the sides, and this time we still have our 60, 60, 60. We want to encourage the right angles. We want to encourage marking the square, and that's so important here, isn't it? So we'll call this x, and x, since we are looking for x. And is this going to be easier or harder for us to compute? Again, we go to our 30, 60, 90 triangle, and that's important. That connection between the square and the equilateral triangle enables us to move on. If we could not relate the square to the equilateral triangle, we would want students to recognize that we would have no hope of solving this. Finding that relationship is one of the important points of this discussion. Solving this problem may be the central point, right? So before it was easy. We knew that x was 3. Here, we don't know that x is 3. So what do we have in this 30, 60, 90 triangle that we have to work with? We actually don't know any of the sides except the long leg, and we don't have a numerical value, we just have x. So now we can go off in a couple of different directions. We could use our 30, 60, 90 triangle relationships first, or we could use our whole side and knowing what one part is. Both approaches are very important, and students should be encouraged to try either way. So either recognizing that this is 6 minus x, and then using the 30, 60, 90 triangle properties or some trigonometry to get an equation, or use the 30, 60, 90 triangle properties first. So I'm going to use 6 minus x because we do want to encourage students to see the part-whole relationship, the additive property. But many students would probably go the other route. So this is the side opposite the 30, the shorter leg, so it's 6 minus x over 2. And then the side opposite to 60 would be 6 minus x over 2 times the square root of 3. So now we have two ways to represent this side. It is both x and it is this expression. Okay, everybody there? Okay. So we're going to solve this for x. I'll distribute, multiply both sides by 2, so we get 2x equals, now I'll distribute the radical 3 to each term in parentheses. Now we've reached the skill part. We all know that many students are getting better at making connections because we stress it now, seeing relationships, but where they falter is with the mechanics. So that's where the balance has to be, focusing on the importance of both strategy, conceptual understanding that is, and the skills of mathematics. So we have 6 radical 3 minus x radical 3. And again, we have some skills. This is not a quadratic. This is a basic linear equation in the variable x. So we'll put the two x terms on the same side and factor out the x. I'm going to skip a step here, so you'll have to figure out the details. So x times 2 plus radical 3, when we bring this term over, becomes positive, equals 6 radical 3. So x is equal to 6 radical 3 over 2 plus radical 3. We could rationalize this. We could go to our calculator and show that the value of this is a little bit less than 3. Well, it is less than 3, no question. But I'm not going to do that right now. If that's the side of the square, then the area you can calculate will be 7 point, let me just cancel that, 7.76. Approximately 776. I'll leave that up for a moment. This is by itself a good enough exercise. This could be a challenging problem on the SAT, the last question, just to find the side of the square. And probably above the level. But they've had questions similar. All right, let me erase this and record our findings coming up to the 16-minute mark, so I may be over the top on this video. Got my marker. Oh, guess I'll take another marker. Okay. Anyhow, let's get my green marker out, which I guess is appropriate. Green for MathNotations, that's my favorite color. So, let's record the second finding of our investigation. Equilateral triangle, inscribe a square, and just as this was 3, now we have that these two are equal. That's important, remember. Key relationships to be labeled. And it turned out that for the square, the area was approximately 7.76. So it may very well be that our original midpoint case was the produced the rectangle of maximum area. Well, let's move on to the general. And I have to move quickly here. So we have an equilateral triangle, some general rectangle, not a square, not connecting midpoints. Again, key step. If we call this X, they have to realize that. Okay, because this is also an equilateral triangle. And if I didn't stress that enough earlier, I should have. Once again, proper labeling, 30, 60, 90. We could call this Y, use 2 variables, but if this is X, this is once again 6 minus X. Everybody with me so far? So we're going to use the same approach we used in case 2 with the square, and we're going to say this is 6 minus X over 2, and our height is 6 minus X over 2 times the square root of 3. So it looks like the previous problem, but this time we're not going to be able to solve for X. So we're going to build a function for the area, A of X. So now we're bringing in a modeling or a function model, which is Algebra 2 Precalculus. It's so important before we get to calculus to do this. So we know that the area of our rectangle is base times height. So we have X times 6 minus X times radical 3 over 2. I kept it separate like that. I wanted the constant to be separate. Now, without calculus, we know that the graph is an inverted parabola. Its x-intercepts are 0 and 6. By symmetry, we know that its maximum point corresponds to x equals to 3. And now, what did we just discover? Well, I don't even need to figure out the area, since this is the area axis and this is x. The value of the function we've already done, because we know that when x is 3, we did obtain the maximum area, approximately 7.79. We can get an exact value for that area by squaring. Well, not squaring that quantity. What did we do? Now I'm confused. I lost track of this. No, it wasn't squaring. We had figured out what the... oh, I guess this is the area. Yeah, my confusion. It's not x. This is the actual area, 9 radical 3 over 2. So that's the exact answer. That's the approximate answer. The side of the square here is 3. And using some basic algebra 2, we have built an algebraic model, a function model, for the area in general, which depends on the base of the rectangle x. From that, we found that the maximum area occurs when x is 3, and so we've shown that the area of the square, the area of the, not the square, the midpoint rectangle is the one that produces maximum area. Being redundant now, I'll get off. Let me know how you feel. And if I mess this up, be kind. Bye.